Good morning, Ovid Middle School students. This is Mr. Woolley, and we are going to continue our Eureka Math, beginning of our first unit here with Lesson 3, Identifying Proportional and Non-Proportional Relationships in Tables. All right, so let's take a look at our first problem for the day. You have been hired by your neighbors to babysit their children on Friday night. You are paid $8 per hour. Complete the table relating your pay to the number of hours you worked. Well, if you worked 1 hour, and you're getting paid $8 for each hour you work, well, you're getting paid $8. 8 times 1. If you work 2 hours, well, you take 8 times 2, and we get 16. If you work 3 hours, $8 an hour times 3 hours work gives you 24. If you work 4 hours, that's 32. 4.5. $8 times 4.5, or what I call 4.5, you can see here. You get $36. If you work 5 hours, you get paid $40. 6 hours, $48. 6.5 or 6.5, you get paid $52. So easy way to fill out the table there. You make $8 each hour. So based on the table above, is the pay proportional to the hours worked? How do you know? Well, yes, there is a constant rate. You're always making $8 per full hour that you work. So definitely that is a proportional relationship. It's kind of hard to fill out the table without that information. All right, let's take a look at our next problem here. For exercises 1 through 3, determine if y is proportional to x. So you're going to find that's a common theme as we go through this whole unit over the next few weeks here. The y values being compared to the x values. That means y has to be done first. All right, and you'll kind of see that in some of the problems we do. So the table below represents the relationship of the amount of snowfall in inches in 5 counties to the amount of time and hours of a recent winter storm. So in 2 hours, this place got 10 inches of snow. 6 hours, they get 12 inches of snow, and so on. All right, so let's take our y values and divide them by the x values. Thinking back to the statement here, I want to see if y is proportional to x. That means y has to be listed first, divided by the x value. So 10 from our y column here, divided by 2 from our x column. 10 divided by 2 means 5 inches of snow per hour. And the labels kind of help based off of what the columns say, inches per hour. Times usually listed second anyways. And then we get to the rest of our values, 12 divided by 6, 16 divided by 8, and so on. And they all kept getting 2 inches per hour. So I would have to say that y is not proportional to x in this table. The rates of snow per hour are not all the same. All it takes is one value to be different. That one county got 5 inches per hour, and the rest of the counties got about 2 inches per hour. So it's not a proportional relationship as soon as there's one different than the rest. All right, number 2, the table below shows a relationship between the cost of renting a movie to the number of days it's rented. So remember, it's y's being divided by x values, okay? So, which you kind of see in my work over here, y's divided by x's. So my y value was a 2, and divide that by 6, and I get 0.3333 forever on your calculator. But since it's money, I got around the nearest cent, which makes it 33 cents per day. And as you take your y divided by x values the rest of the way, 3 divided by 9, 8 divided by 24, 1 divided by 3, I keep getting the same answer. That's 0.3 repeating, which in money terms makes 33 cents. So that, in this case, yes, the y, the cost, is proportional to x, the number of days. There is a constant rate, 33 cents per day. It's consistent throughout the whole problem. All right, a couple more examples for you here. Number 3. The table below shows a relationship between the amount of candy bought in pounds and the total cost of the candy in dollars. Once again, we'll take y values and divide them by the x values to see what our unit rate would end up being. So y is divided by x's. 10 divided by 5 gives us $2 per pound. 8 divided by 4, $2 per pound. Now if I keep taking my y's divided by x's, I keep getting $2 per pound. So once again, yes, there is a proportional relationship of that cost to the pounds of candy. It's always $2 a pound. All right, one more to look at here. It says Randy's planning to drive from New Jersey to Florida. Every time Randy stops for gas, he records the distance he traveled in miles and the number of gallons used. Assume that the number of miles driven is proportional to the number of gallons consumed, or complete the table. Well, the first thing I want to do here in this table is to find what that unit rate is going to be, because I've got some parts completed, like here and here, but the rest of the holes need to get filled in. So I find the unit rate, the miles per gallon. If I took 54 miles divided by 2, I get 27 miles per gallon. And even if I tested out another one that gave me the complete set, 216 divided by 8, I get 27 miles per gallon. Well, if that's the case, if I get 27 miles that I can travel on 1 gallon of gas, well, if I use 4 gallons, 27 times 4 lets me fill in the box of 108. And over here, I can use 10 gallons of gas. So 27 times 10 gives me 270 miles that I can travel. And same thing with 12 gallons, 27 miles per gallon times 12 gallons gives me 324 miles. That does leave one up here though, all right? The gallons one I did not have. So what I need to do here is to work a little backwards. Here I was multiplying to figure out how many miles I could go. Well, if I have to work a little backwards, instead of multiplying, I would use division. So I'd take 189 divided by 27, not 27 times something to get the miles. I take the miles divided by 27, and it tells me I have 7 gallons I ended up using here. So, all right, now there is a homework assignment that you'll see in Schoology, so make sure you give that a shot and wrap that up, and we'll see you later. Have a great day.